Hello, everybody. Welcome. We're ready to roll? Yes, we're ready to roll. In a world of advanced research in arts and engineering, it's where art is usually not given much of a place. We're very fortunate to have an institution that maintains a strong commitment to artistic practices and provides a structure for their support. And so I want to start off by thanking Ramesh Rao and the incredible staff at Calit2 for making these projects possible and for executing the exhibitions we do with such professionalism. So congrats or thank you to Trish Stone, Hector Bracho, Ruben Huerta, and the many others who work on these projects. We're very grateful for all your efforts. And the research-driven artistic practices that the gallery presents are exemplified most compellingly by this particular exhibition, Earth Sky, dedicated to environmentally engaged artistic projects organized around the meeting of horizontal and vertical axes, ground and aerial perspectives. And so I'm pleased, first of all, to introduce our two curators, Ryan Bishop, Professor of Global Art and Politics, and Jussi Parikka, Professor of Technological Culture and Aesthetics, both at Winchester School of Art in the UK, where they also direct the Archaeologies of Media and Technology Research Group, among many other projects. They will introduce the conceptual framework for the exhibition and the two artists who are with us today, Susan Schuppli from London and Femke Herregraven, sorry Femke, from Amsterdam, whose presentations will immediately follow. We will kick off the program with a screening of Susan Schuppli's Atmospheric Feedback Loops, a film shot in 35 millimeters in a vertical format in collaboration with climate scientists in the Netherlands. After these presentations, we will have a short discussion and then we'll move on to our opening reception. So, welcome, and on that note, we will go ahead and begin with Susan Schuppli's film.
In a rural landscape approximately an hour due south of Amsterdam, an open-air laboratory is tuning in to the atmospheric frequencies of nature. Separating the signal of climate change from the noise of cyclical variability. Since 1970, the Cabau Experimental Site for Atmospheric Research has been measuring and monitoring the changes taking place in the feedback loops between land surface processes and the airborne dynamics of our planet. Studying the ways in which the complex behavior of clouds, aerosols, radiation, precipitation, and turbulence interact with terrestrial events.
Feedback is a very important concept in climate science and in weather science and atmospheric science in general. Because if you have a system and you distort the system a bit on the input side, then the system will respond to this. But this response might impact the input change again. And you have to know this, because this feedback loop that you have in a system might make the final response of the system either far worse, it may amplify it, or it may diminish it.
Using instruments that sample the wind and take temperature soundings, devices that scan the bandwidths of storms and track wavelengths as they move through different atmospheric densities, sensors that detect the infrasounds of geological events, and tools that scatter the particulate matter of air. Scientists working here are producing an extraordinarily comprehensive and evolving data set that feeds Dutch light and sound back into the global climate model.
My name is Herman Russenberg. I'm a professor of atmospheric research in Delft. And now we're here in the Cabau Observatory. It's called CSR Observatory. It's a very old one. It started 45 years ago for wind and turbulence measurements. Our main goal here is to connect everything that we have in one column over here, and you can see the tower, which is 200 meters high. One column starting at -1 meter, so in the ground itself, where we have soil moisture, vegetation at the surface, up to the top of the atmosphere, which is about 12 kilometers above our heads. We want to connect all the phenomena in there and try to understand how every scale of atmospheric phenomena connects to another scales. What happens, for instance, at a smaller scale when you talk about molecules? So molecules of trace gases or water vapor. How are they connected to the formation of dust particles? And how are these dust particles connected to the formation of cloud droplets? And how are these cloud droplets connected to turbulence, because they transport the droplets up to the atmosphere? And how is this connected to the larger scale wind patterns? And how is this connected to the global circulation patterns?
We look at the atmosphere, when we listen to the atmosphere. Because we are humans, we have to interpret our measurements. So we'd like to make them audible or visible to ourselves. That's the visible and the audible fingerprints that we're looking at. The atmosphere makes a lot of sound, as you can hear right now. It's raining. But there's also sound that you cannot hear. We call that infrasound, because the tones are so low that your ears cannot hear it. We have devices here in Cabau that are dug into the ground, and they measure actually very low frequency pressure changes in the air. So whenever an airplane passes over, it creates a wave and we can detect the wave. But there are also other things, like if a volcano erupts, that also triggers, well, waves in the atmosphere, and you can hear that. So maybe not with your ears, but with these devices that we have here in the ground.
We have what we call active and passive instruments. Passive instruments sit and watch. That's all they do, so they measure all radiation coming from the atmosphere. With an active instrument you can manipulate the properties of the signal to measure the properties of the clouds or aerosols at a larger distance. Most commonly used instruments also here is radar and LiDAR.
You saw the green lights coming out. We send out this into the atmosphere, and then it reflects off clouds, but also dust particles, the aerosols. Because the LiDAR uses very short laser pulses, it works like an echo.
There's another instrument that you can hear every now and then called a wind profiler, and it transmits a sonic beam into the atmosphere, and a local distortion of the air density translates into a local distortion of reflection properties for radar waves. So you create your own acoustic wave, you use a radar to measure the reflection by this acoustic wave, and then we know from theory that the sound of the wave is linked to the temperature of the Earth. Noise is seen as a distortion. So we have thermal noise in the receiver itself, so that's the electrical noise generated by the instruments themselves. But we also have noise from the outside, so if you do a measurement, it's not only the cloud producing signal, it's also other things. A bird might produce a signal, an airplane might produce a signal. That's noise to us. When you talk about noise in this concept, so signal in comparison to noise, then noise is just something we don't want. On the other hand, if you do a pure measurement, then what you mainly measure is pure noise. Because if you look at the unprocessed data coming from the clouds, it's like noise. And we use our processing to get the signal, the data, out of this noise. Because it's hidden in there somewhere. But of course, when you talk about the climate system, it's a system with different time scales and different spatial scales. Time scales are important. Of course, the climate has been changing ever since the Earth was there, and the time scales of these changes are very diverse. And if you want to get a good climate model, you have to include these time scales. And for this, you need long-term observations. How was the temperature the last 1,000, 10,000, 20,000 years? How do you get the data of such long time records? Before we had the instruments, we didn't measure temperature, so we have to look for proxies. For instance, the size of a tree ring depends on the temperature of the particular season. So if you can analyze these tree rings, you can know something about the temperature of those days. So you can drill a hole in the ground, and you can look at changes in the geological structure of the Earth. If you, for instance, drill a hole in the ice and you look for captured air bubbles, then you're looking at air of 200, 300, 1,000 years ago. Scientifically speaking, it's the present and the past have the biggest value. That's where you can collect data from. The future has a moral value.
A story is repeated here at Cabau. The artist Joseph Beuys once theorized that the unique atmospheric properties of light, which had inspired Dutch painters since the 17th century, had disappeared with the land reclamation projects of the 1950s. As post-war modernization began its terraforming operations throughout coastal regions of the Netherlands, the air was said to have lost its refractive shimmer due to the diminished number of water molecules carried inland by prevailing winds.
We use a painting from the 17th century landscape painter Jacob van Ruysdael. In fact, this is what he painted, the Dutch skies. Well, without knowing it, he recorded all the complex things about atmospheric research that we're studying.
The scientists conducting research here are recording even more dramatic changes as atmospheric feedback loops between land, sea, and air reveal long-term amplification of climate change signals. Terrestrial, aquatic, and atmospheric mediums have been forcefully remixed, creating radical new forms of unnatural media.
Hello? Yeah, okay. All right. Thanks everyone for coming. I'm Ryan Bishop. This is UC Parikka. And we'd like to thank Jordan for inviting us to curate the show, and thank Trish and Ruben and Hector for all their hard work in getting it set up. Before we leap into just a few introductory remarks, I wanted to make a brief historical link between Susan's film and UCSD Department of Arts. In the early 1970s, Alvin Lucier, the sound artist, was here, and with Pauline Oliveros, they created a work called Spherics, which has made the rounds in a number of different galleries using similar atmospheric feedback loops. So it's nice to kind of ground us when we're thinking about XY axes. Okay, so we're going to trade off some comments that will help frame and contextualize some of the ideas behind the exhibition. Where the vertical X-line meets the horizontal Y-line in the XY axis is called the origin. Although we are not going to pursue myths of origins in this panel, that intersection is certainly the origin of inspiration for our exhibition and the works that comprise it. What is the relationship between the XY axis and the horizon? Where is the horizon in the XY axis, and how is it constructed, reconstituted, erased, or negated by the visualizing technologies these artists deploy, explore, exploit, and query? The question of the horizon in relation to technology generally emerged in its contemporary guise in the aftermath of World War II and remains with us, cast by Martin Heidegger, as the age of the world picture. The telecommunications technologies developed to provide constant real-time surveillance of the Earth necessary to conduct the Cold War and enforce the Truman Doctrine simultaneously converted the Earth into a globe that is a bounded sphere visible at all times, as well as into a flattened surface without horizon, due to the use of over-the-horizon visualizing technologies and complete surveillance of the entire planet, all at the same time. It found visual form in two works that were produced about the same time that Heidegger was writing his essay on the age of the world picture. One of these was Buckminster Fuller's Dymaxion Air-Ocean World Map, and the other is Jasper Johns' large-scale painting for the Montreal Expo, inspired by Fuller's map. The multi-piece and multi-shaped canvas painting measures more than 30 feet long and over 15 feet high. As with Fuller's cartographic vision, the icosahedron Dymaxion map created by Johns could be disassembled or assembled at will. Fuller's map could be folded together to create a sphere, or unfolded origami-like to be a flat two-dimensional object. Co-created with Soji Sudao, Fuller's map provided the model for the interactive, data-driven version of a pedagogical, real-time technological teaching tool called the World Game. Fuller and Sudao's map moved easily then between 3D and 2D representations of the Earth's continents. These, the continents, were represented in size based on population, distribution, and resource usage, instead of the standard cartographic nod to land mass coverage. Fuller's optimistic vision of the map's pedagogical elements was at odds with Johns' more pessimistic view of the geopolitical agonism that marked the moment. The map mimetically reproduces fully, then, the age of the world picture. The globe as stage for Fuller-inflected neighborliness also became a site of contiguous land masses locked in Johns' depicted animus, 3D holistic vision coupled with 2D Cold War strategically generated economic inequities. The cultural politics of Heidegger's interpretation of modernity's generated metaphysics can be charted in the capacity for representation to equate with both experience and the real, for the map to create the territory and the technological means for cartographic representation to become the tools for human crafting of the Earth as globe, as flat, observable plane, or as Fuller occasionally defined it, as spaceship. The visualizing teletechnologies on display in the Dymaxion map, as well as the works in our exhibition here, are just such tools, for they chart a trajectory in which the world traveled from being construed as plane to orb to globe to flat surveilled entity again. Our capacity to see and render the planet whole erased the horizon of the world and made it capable of being held in our collective teletechnological grasp. This is the negative horizon theorized by Paul Virilio, the conversion of the surface of the earth to pure surface, pure plain, to salt flat deserts and mineral cemeteries, a screen for projections and visions, a platform for unfettered terrestrial and aerial acceleration and optical realization. The age of the world picture is evoked in these maps made by Fuller and Johns, and it is so in means by which we have enframed, delineated, and curtailed potential futures, realized or not.
So this leads us to the works that are on display in the actual exhibition, including the one we just saw, including atmospheric feedback loops by Susan Schuppli. Schuppli's, the one piece in the galleries, Schuppli's nature represents itself, presents the deep water horizon oil spill in its legal and aesthetic form to propose the ecological site as a material witness, capable of representing its own damaged condition. This auto-representation of environmental disasters posits a new medium unique to the components of the disaster itself. In many ways, this is a visual analog to Reza Negarestani's philosophical fiction that fabulated non-human revengeful force of petroleum in the book Cyclonopedia. But furthermore, it also taps into the multiple camera angles of the Anthropocene. The live feed of the underwater oil leak, the aerial view of the region as a massive size oil painting, and also Übermorgen Art Group coined it, the TV footage, the scientific imagings, and so forth. Concerns about the horizon are omnipresent in the name of the documented disaster itself, of course. The deep water horizon oil spill, with its connotations of X and Y again. But also depth as the passage to the underwater realms that link from Jules Verne's fictional Captain Nemo's megalomaniac world tour to the as megalomanically disastrous seascapes of drilling and deep-sea mining. While the melting Arctic ice that will flood vast coastal areas and towns presents new northern transport passages as well as oil and mineral opportunities, we are left with an archive of disasters. An archive of disasters that already have taken place and will take place, have already taken place across the petrocultural century and a bit. Deepwater is one where the various axes again are brought together, both in terms of the spatial coordinates, but also ways of making sense of it in terms of a visual culture of disasters. The Gulf of Mexico was made into an unintentional canvas of human intervention and failure, as seen in the many images of the disaster taken by NASA's pertinently named Terra satellite. The visual register on screen in Schuppli's work is that of the accident, which is a recurring feature of the axis where visual culture and technological infrastructure and political decision-making meet. As Virilio constantly reminded us, the invention of any technology is also the invention of its failure, of its accidents. Technology in its operation and its failure provide equally fodder for imagination planning, speculation, aesthetic production as well. This also applies to the speculative side. Not merely inventing technologies, but inventing accidents in the first place. Inventing their accidents around which technological systems can be laid out, take form as large scale systems or accidents. Virilio in fact posited that the history of technology could be better queried and understood through a museum of disasters than our usual technophilic celebratory institutions. If such an institution, if such a site were to be built, Schuppli's work could take a proud place as one example of the long-term legacies of petrocultures, as invention of an accident around which modern culture takes place, from transport to industry, from lifestyle to the variety of materials that sustain our sense of the everyday.
Another kind of accident lurks in Herregraven's sprawling swamps, which is on display in the gallery. A series of fictional infrastructures dispersed within the cracks of the contemporary financial geography that operate on a technological, legal, and social level. Herregraven's focus is on the literals, the ambiguous shifting zones where sea and land interact, the port and the portal interface. These ambiguous and ambivalent spaces, gaps between economic and environmental certitudes, speak to Paul Gilroy's arguments for a critique at sea level. Picking up from Gilroy, Francois Verger asks, how do we develop cultural theory that starts from water, the sea, the oceans, from the Middle Passage, but then also the Northern Passages, the various forms of colonial and other kinds of disasters, including contemporary ones that take place across liquid and swampy landscapes? What is sea level in the current moment and in this moment of warming currents? Increasingly, land can become water. Arable land can become desert, etc. in this weird mixes of the classical four elements from antiquity. As Gary Ganosko puts it, these four elements are not, however, any more stable than the sort of earth, water, fire, and air that was posited in the past. A longer quote from Ganosko gives a clear picture of the new synthetics of elements. Quote, the new fundamental elements, earth, dust, water, blood, air, lethal fogs, fire, flammables. Wrapped around these elements is the planetary phylum, a great Tellurian cable bunch with its own products, earth, electronics, water, liquidities like water bottled in plastic, which throws forward diagrammatic intensities in the explosion of plastic debris. Air, gases, greenhouse, and fire, smoldering car tires, slashed rainforests, and seasonal wildfires in the great northern forests and in the hills nearby here. However, as we have seen, the new elements combine both in existing directly, blood mixed with dust in the extraction of conflict minerals and oil fields, or methane, a flammable unnaturally mingled with the water supply and which contributes to the greenhouse effect. And by means of especially communicative matters like microscopic fragments of plastics that perfuse the oceans and get into the food chain and constitute fine dusts that affect respiration, settling among the fogs, gases, and legal clouds, end quote. The Ovid-like metamorphoses of nature, of body's change, operates in pre-Socratic thought in relation to the elements with the universe composed of these four elements, battling or playfully transforming into one another, as Empedocles theorized. But from Empedocles, we should also move further to the chemical period of the past 200 years of chemistry and its multiple forms of interaction and escalation of planetary deposits. What we are witnessing now is a rapid reshaping of the elements of the planet, some by design, but most not, some by human actors, and some by technological systems working autonomously or in tandem with others in unintended ways. The dynamic nature of matter and of nature finds form in precarious legal, financial, and governmental infrastructures poised along the liminal littorals. Nonetheless, urban human forms as a guiding set of imaginaries are seemingly impervious to the vicissitudes of unstable ecologies, in spite of high winds, hurricanes, typhoons, floods, drought.
Visualizations of the XY axis actually rarely show the air or the sky. The seeming transparency of atmospheres is, however, a source for another sort of light media and sky media that is often crystallized in technological figures such as drones or satellite infrastructures, and then perhaps also the toxic legacies that are visible in ways, in a way like smog is, but also includes the longer legacy of aerial perspective, sightlines lifted from the ground. We most often see the Earth as surface, with the X-line being the literal line of sight. The horizon is often usually implied what we know lies beyond the frame. Also in the gallery, Heba-Amin's lyrical and witty projection piece, As Birds Flying, allows views of the sky, the earth, the horizon, savannas and wetlands, settlements, aviary migrations, which in turn allude to human migration on the rise throughout the world. Her use of found footage and non-human surveillance techniques, in this case mistakenly believed to be strapped to a migrating stork, reveals horizons of visualization, tracking, and a continual geopolitical struggle for contested terrain. It starts also not as a stable view, but it starts as one in movement, a survey of landscapes and velocity, of movement and tracking, of cinematic visions projected onto daily existence. It is worth noting that the aerial views on view in the show now are visible by humans, but the majority of these images of Earth surfaces are being produced today are actually by machines and for machines. They're not representational or indexical at all in the traditional sense, but they are informational, and surely they are automated. This is what Harun Farocki coined as the world of operational or operative images, which also includes an increasing amount of environmental imaging. These are also a dominant strand of the Earth, sky, and XY axis visualizations of the present that expands from aerial views to soil analysis and to interplanetary visual cultures, as with the recent Mars rover images too. These images are used for data. The relation to aesthetics as we used to think about aesthetics might be quite casual only. Despite that, times glamorous views we get a glimpse of and we celebrate, oh, this is what Mars looks like. That which isn't visible can be translated into data visualizations that then help feed a vast machine of surveillance, charting, control, but also, importantly, prediction. In so doing, the XY axis extends to include the Z-axis, and we enter into a predictive temporality, planning, investment, policing, and so forth. The role of dynamic systems such as weather and climate, of course, in futures markets, from crop production to mineral extraction, along with other kinds of uses, results in manipulation and prediction that links governmental sovereignty to data visualization techniques and the capacity to shape and generate financial systems and markets. So if we talk about surfaces, the particular surfaces that are catered as massive data sets are the past archive for the hypothetical future nows that open up a new horizon. Questions surrounding large-scale production of pre-mediated near-future predictive strategies linking geomedia to algo trading speeds up the Earth, as the manipulation of the materials for control and gain, set the data gathering agenda in despite of the many admirable and altruistic projects that may complement it. In this way, the images and predictive data that is scraped from them, it replicates bureaucratic tools of domination. So, as the media theorist Sean Cubitt writes, and I quote, that trinity of fundamentally bureaucratic media, as in databases or filing cabinets, spreadsheets, ledgers, and GIS maps still operates, not least at the level of companies and institutions where it continues to provide the backbone of a residual early modern biopolitics, end of quote. So these instances of administration, Cupid continues, were the dominant media of early 21st century because they were media of domination. So the techniques and technologies have changed, but actually the larger cultural techniques and their ontological rationale have not. Hence, the origin of XY axis remains literally and figuratively in place, if not accelerated and compounded by our visualizing technologies. Thank you.
Thanks.
And next, I want to welcome Femke Herregraven, who's going to continue on her project and give more context about that, after which Susan Schuppli. But it's all yours, Femke.
And, I wanted to start that I didn't have such a consistent and concise story as the previous speakers, but I think this became a bit more messy than I thought. I will try to go through it really quickly. This is just to give you a bit of context of the work I'm showing here. This is another exhibition called Sprawling Swamps. The work, in a way, it's a sort of, you could say it's almost like a meta work that contains a lot of case studies and projects that I work on in my practice. As an artist, I've been working on global finance for the last 7 or 8 years, and often in relation to geology and landscapes. Just to show this image as maybe the y-axis, this is a screenshot of a high-frequency trading disaster, flash crash of 2010. And I was working on this when I just graduated 2011. And the thing I started doing at the time was thinking, like, what is the physical infrastructure behind this trading, behind global trading, not only high-frequency trading. And just to show you some images, of course, submarine cables are really strong element in that backbone. These are some video stills of a video project that I work on since 2011, which basically is about capturing the cable landing points around the world of internet cables, submarine cables. So this is Mauritius, France, Curacao, Indonesia, France, also Mauritius, the Arctic. And just to give a bit of context for what will follow, this is in 2014 when I was in the Arctic, and I was there on a residency, and I wanted to go to this particular place because it's kind of a projected place in the kind of upcoming new submarine cables. I was here in the north west of Russia, in Murmansk, and as it turns out, this will be a location where the submarine cable road tax is planned in the near future. This is the first submarine cable that will cross the Arctic Ocean floor. This is only possible because of the melting Arctic ice at the moment. And as it turns out, traders are really excited about this future cable because it will cut the trading time between London and Tokyo at 42 milliseconds. So in this case, less ice means more money in less time. So this a bit as context, when I started thinking about the relationship between unstable terrains, the melting Arctic ice, and financial value. And I started thinking about how do you even govern a place that is sometimes ice, then it's water again, and how do you actually speak about these unstable terrains also in terms of infrastructure. So these are just some fragments from the research at the time. This is, for example, icebergs broken off from Antarctica floating up north. This is a submarine volcano that erupted and created a new island in front of the coast of Pakistan. That still exists, but probably it will erode in a matter of 2 years. So what is the status, or like how do we even approach a place like that? Also, what was interesting when I started looking more into these kind of temporal places or places that were eroding or emerging, that often, in terms of satellite footage, is not such a HD precise image. It's often a patchwork of different ones. And this became a kind of input for this work, Sprawling Swamps. Basically, it's an interactive, it's an application, it's a sort of interactive 3D world that allowed me at the time, it started more for myself as a research tool, to think about, let's say, computational infrastructure on a global scale and to work with this global scale. So these are some screenshots from the application that you can also see as a video here in the exhibition, just to give you a bit of context. Sometimes it's presented like this on a docking station or like this. And you see here these black boxes on the left. FedEx is still holding them in customs, so we're waiting for them. Another nice element, unstable element in this presentation. But basically what these black boxes show is the different chapters that are in the application, because each project, each case study becomes a chapter. Let's say each project or case study, it's very much something that emerges through journalistic research, collaboration also with journalists or scientists sometimes, going to these places. But it's also a project that allows me to kind of speculate on places that I don't have the means yet maybe to visit or work on. So it's a kind of growing element. So here you see the chapters, the locations where they are. And I just want to briefly take you to two of them. So this one is called Raft for Displaced Matter, and it's located in front of the coast of Java. This place is important because there's two, we could say, Victorian disasters that took place, and which I think I speak about contemporary, our contemporary global infrastructure of computation. So this map, maybe, I think some of you have probably seen it, but this is in a way quite similar to the map that we have of our internet cables today. But this is a map from the 1850s made by the British Empire. And this project that they, in a way, propose here and also executed was called the All Red Line. And the idea was to create a faster communication network between Britain and its colonies. And so there was this new technology, the telegraph line. And so the idea was to connect all the colonies without going over hostile territory. So this is those red lines. These are just some fragments, newspapers from the 1850s, where you can see they're introducing these cables and the technique to the audience. What was interesting at that time is that the Krakatoa eruption happened in 1883, and this was supposedly produced supposedly the loudest sound that has ever been heard on the surface of the earth by people. Also, its sound waves supposedly traveled 4 times around the globe. And what was interesting is that this moment could actually be documented through recording devices at the time in the world, but also because this telegraph line was in place and news could travel fast. So this news about this eruption traveled actually quite fast. But of course, the infrastructure that made that news travel fast was in itself also a kind of disaster. Here on the left side, we see a fragment of those early submarine cables, telegraph lines. On the right side, we see something that you could see is similar to what coltan is to our mobile phones and devices, a sort of holy grail. It's the Gutta Percha plant. This plant only grew, this tree actually, in the Malay Peninsula, Indonesia and Malaysia. And I was doing this research, and I found that the Dutch former colonial museum, the Tropen Museum it's called, in Amsterdam, that it had these images of this rubber plantation, Perca Gutta. Perca Gutta is a natural rubber, and they found out in a way by accident that this is resistant against salty seawater. So this became super important in this new early infrastructure. Here you see some fragments, some images, photographs of that time. Here they're plucking the leaves. Here they're drying them in the attic. Here they're grinded. Here as well, just to give you some context of this production process. And it was interesting because when I was researching this, in a way, material history of this network, something happened. I was following these beach bomber forums online, And people started posting these strange blocks that they found. They were not really sure at the time what it was. Here you already see screenshots from Twitter when this thing was picked up a bit later. And I like how people are posing with these blocks as if it's some sort of trophy, but in a way it is also. I recognize these shapes from one of the pictures that I got from the museum. And you can see them here, this image, it should be 1894, not 1994. These are Parikka blocks. They were melted like this in these casts, in these shapes. They were shipped to London where they were turned into these submarine cables. And so one of the chapters in a way speaks about that. I quickly go through this. One of the other chapters speaks about another component. Because what happened is that eventually I got 3 of these blocks myself. One day I got a phone call from someone who said, I cannot say my name. I have something for you, and I want to let you know they're not from the Titanic. And I said, oh, well, I kind of know that they're not from the Titanic. And they sent me these 3 blocks in the mail, in a garbage bag. And it's quite bizarre because, of course, this is rubber from rubber trees in Indonesia. And why are they washing up on shorelines? It's because the ship that was on its way to London sank. It was on the bottom of the ocean for more than 100 years. And now these tiles are popping up in the coast of France, Netherlands, UK, but also Japan and Curacao. They're following in a way the currents of the sea. So this ghost from the past come washing up on shore. I wanted to, in a way, use them to reflect on something else I was working on at the time. And this is an image that explains it a bit. The tube on the right side is important. It has geographic coordinates, like you can see here. And these coordinates respond to these calculations that I really cannot read myself. But they're from a report from 2 MIT researchers who were asked by actors from the financial world to calculate how high-frequency trading could be made faster around the globe. And they calculated what they called a treasure map, which is based on this very simple principle that if you want to exploit a price difference between 2 stock exchanges in different places around the world, you need to be exactly in the middle to know what that price difference is. Mid-location points, they call it. And so this is a map I kind of visualized from their research. Basically, all the white dots are those mid-location, as you can see here, which means that at the moment they're kind of planning this sort of floating infrastructure in order to make high-frequency trading faster. I mean, to me it's very sci-fi, but I think it speaks about a kind of new network that links to the old one. So this is a series of works where each tile, this is the Arctic series, carries one of those coordinates from that data set. So it is a ghost from the past, it is a cast of the original tiles, but it also speaks about a kind of future projected infrastructure. And it's in the work like this. This is the chapter. I'm kind of okay still. I'm almost, maybe 3 more minutes, yeah? This is another chapter. And this is based on a research that I'm still in the midst of, but it concerns an area in the north of Ethiopia. This area looks like this. It's a very intense landscape. This area is called the Dymaxion. It's a crypto depression. It's one of the hottest places on Earth. It's, to be said, one of the cruelest places on Earth for people actually to be and live. So you have a nomadic movement of the Afar people that move between Eritrea and this area. But it's also a place where NASA started, I think since last year, organizing expeditions to research what life on Mars might be like, because they expect extremophiles to be present here. It's also the place where Lucy, our ancestor of I don't know exactly how many years, but is found. So it's a very, there's a lot of projection on that place. It's also a place where salt trade happens already for more than 2,000 years in a similar way with camels. So from high frequency trading to extreme slow trading, you could say. Salt was also the currency in Ethiopia for more than 800 years. And when I was there, it was quite interesting. I came back and I found out that actually mailbox companies owned by Israeli mailbox companies, owned by Australian mailbox companies, that in Amsterdam actually the final mailbox companies at the end were located around the corner of where I lived. And they, in a way, manage the mining industry that tries to take off in this area already since 1908. But because the landscape itself is so in movement, dynamic, this is still up until this day not really possible, any industrial mining. And so there is something, I think, poetic in that the landscape kind of resists this monetization of the landscape itself. But also when you think you're traveling to the most far place maybe in the world, for me, someone from Amsterdam, eventually the financial infrastructure arrives back literally next door. There's a 3-channel video that, oops, yeah, I have image here. I see it on my screen. Oh, okay. This time is not the power, but yeah, maybe, yeah, we can leave, yeah. Yeah. Yes, we can leave it at that, thanks. Okay.
Okay.
Do you?
No, I mean, I'll just go ahead. I thought we were going to have a little bit of a discussion, but I think we're running short on time. I don't have any visuals. I can just say a few words about the project that's presented in the exhibition here. And Femke, I'm not trying to push you out of the way. Yussi's already mentioned some of the kind of key attributes. This is not I'm talking about the project that relates to the Deepwater Horizon oil spill. So just that's a portion of a larger installation that I presented at Sculpture Center last year. And maybe to give a bit of a snapshot of that project, what we have here is a simulation of hydrocarbon atoms that have the very specific kind of properties of the same crude oil that was obviously gushing out of the damaged deepwater exploratory kind of drilling rig, and it's a simulation. And I'll explain that in short order. On the headphones, you have an audio track, and that audio track, that's the indictment that Ecuador has a Pachamama constitution which recognizes the legal rights of nature. And when the accident happened in 2010, Ecuador, under the principle of universal jurisdiction, filed an indictment against British Petroleum on behalf of the rights of the sea. This is a very radical, if you will, legal move that was made on the part of Ecuador. It was ultimately unsuccessful, but it was a legal provocation that I think is really kind of important because, of course, it challenges one of the kind of, there's a fundamental hurdle when it comes to litigation for environmental crimes, and that is the fact that criminal law has the burden of direct causality. It requires that one prove the condition of direct causality, so perpetrator and sort of victim, if you will. So this condition of direct causality has really hampered environmental justice. So generally what happens, environmental violations get litigated under toxic tort law. That is to say, one would companies, such as British Petroleum, would pay compensatory damages, so financial payouts, but there will never be any finding of kind of criminal responsibility. So the lawsuit that was filed in Quito is quite extraordinary, and if you listen to it, both the indictment and the claims that are made and the demands that are made to BP are also, I think, a fairly kind of, they propose a set of kind of unique kind of legal principles. So that's sort of one element. And those of you who might know something about my work, the kind of entanglement between the law is always one of the kind of key components of the projects that I produce. Another element, another dimension of the project, and Jussi mentioned this a little bit, it was the, and of course, I'm talking to obviously people living in the United States, so you might well have been aware of the fact that, so BP at the time of the accident effectively tried to control the news cycle by banning access of any kind to the Gulf. They rented out all of the motel rooms. They prohibited the flyovers by helicopters, et cetera, et cetera. Most of the images that first appeared were the images taken by the US Coast Guard, sort of sanctioned image providers. This produced a set of conditions on the ground. So we see the emergence of the activist group Public Lab. Public Lab they produce what they call community satellites. So they use kites and balloons with cameras attached. And so despite this sort of media ban, so Public Lab did manage to start to produce a set of kind of visuals that were able to document the encroachment of the oil towards, at this point, towards sort of land. So clearly these balloons and kites were not, were not able to capture the spill in its sort of early days. So it was much more the damage as it was moving towards the actual coastline. Automated forms of image capture, such as all of the Earth observation satellite systems. So despite BP's de facto media ban, all of the different Landsat, Aster, Terra satellites, they were all capturing images of the spill as its sort of kind of tentacles were moving across the Gulf. We also had the underwater video, the live video stream, et cetera. So I was very interested in all the sort of media responders to the event, also BP's media strategy. But in particular, there was a kind of mediatic agent that was overlooked in that, and that was, of course, the spill itself, which is, technically speaking, an oil spill is an oil film, and it's because of the specific ways in which hydrocarbon atoms interact with water. They produce interference patterns. They bounce light around, and so they have a kind of quasi or proto-cinematic capacity. So I was also trying to argue, in as much as one can make a conceptual argument about the kind of legal agency of nature, one can also, I felt, and I do feel, make a parallel argument about the kind of aesthetic agency of some of these kind of damaged ecological systems. So, and of course, not only is the oil spill it is an actual oil film, but if the origins of celluloid cinema are in fact themselves derived out of the sort of metabolic origins of petroleum as well. So the project and what you're seeing here is in some way my attempt to make a kind of conceptual argument in part, coupled with the legal audio that actually tries to locate that conceptual argument within a very specific geopolitical condition. And the one thing that, the challenge that I sort of faced, which was like, okay, if I want to forward an argument about the kind of self-imaging capacities of damaged environmental systems, might sound somewhat counterintuitive, but in fact there's lots of precursors for looking at the ways in which environmental media has then become has been environmental phenomena have produced certain kinds of technological innovations. So a classic one would be the like flash photography found its origins in the spontaneous illumination of lightning. So there's many of these kinds of analogies, and some people refer to them as sort of elemental media, the resonance of wind, etc. So this kind of very long-standing relationship between environments and sort of media, and the kind of technicity moves across the natural and the let's say, the anthropogenic kind of domain. Photosynthesis in plants, of course, is a proto-photographic kind of technology, if you will, the capture of direct energetic quanta from the sun, a chemical reaction, and the transformation and production of some sort of visible surface effect. So this is, once one starts to enter into this kind of realm of research, very quickly you realize that there's actually a very strong correlation between the kinds of ways in which certain contemporary, say, earth scientists might be operating, and some of the interests of contemporary artists. So that's really where I'd like to locate my own practice. And maybe the final point that I would then make is I was faced with the challenge about how do I actually produce a project that is trying to, as I say, forward this argument around the sort of kind of self-imaging capacity of the oil spill. So I thought, well, I wasn't just going to like fake an oil spill. So I thought the best solution in my mind at the time was to produce a kind of simulation where the image that you see in that simulation is an image that is manufactured by running millions and millions of particles in a piece of software called RealFlow, where all of the particles have the very specific attributes and viscosity, et cetera, of particular hydrocarbon atoms. And so when you run a simulation like that, so that image that we're seeing is an image that is being produced by the sort of software. And so that was, so that's a little bit of insight into the project. And so that was the kind of my resolution to the sort of conceptual challenge was, so I chose to actually in some way move the entire argument into the kind of domain of computation. But anyway, I hope that gives you a little bit of insight into what's at stake in the project. And of course, there's many more materials that I think would help sort of shape that sort of larger project. And you're welcome to explore some of those. I have them on my website if you're interested. You feel free to take a look if that would sort of flesh out the project a little bit. So I think I'll leave it there. And yeah.
Thank you, everyone, for bearing with us through all of this, and thank you to our guests, particularly. I think we've decided that we're going to move on to the opening, and sometimes the most interesting conversations happen afterwards from these types of events. So we really invite you to stay around, have some food and drink, and talk with our artists and curators, and enjoy the exhibition, which is going to be running for a while tonight. So please join us outside, and please join me in thanking our guests today for their presentations.